This is probably the world's coolest aquarium light. It has a circular design that shines light from all directions. It can simulate daylight cycle from dusk till dawn, and weather patterns like heavy rain or a meteor shower, even the apocalypse. Not only that, but it can also be controlled with this aesthetic app that my friend built. And in this video, I'll detail the process how me and my friend built this in just under 24 hours. I've seen like all sorts of aquarium lights. Most of them are in the form of panels like this, and are paired with a cheap Chinese app for controls. Some cool ones that are in the range of a few $100s have effects like daylight simulation, but it's still just a color change and doesn't show the sun direction like in real life. What if we can create a light that actually simulates the sky with sun direction and is controlled with a beautiful, usable app? This is the light itself. Yeah, it's a WS2812 light. It basically should have 3 pins, one data in, and the other is ground, and the other is just 5 volts, to power the device. And we have some microcontrollers as well. It's the same thing as this one. Can you see? Yeah. So it's called an ESP32S6 or C6. C6. Yeah. So it's not an ARM core or an extensor core, but it's actually a RISC-V core. Sky message.
Yeah, we could send some kind of state and then you can do whatever.
Yeah, and that state would contain the time of day. Because these microcontrollers, they don't have a clock. They do have a clock that they can count time, but they don't have an exact clock where they know the exact time of day. So in basic mode, you can change the color. In sky simulation, you cannot change the color. What you can do is you can add in effects.
And send it like rain, sunshine,
yeah,
cloudy.
Yeah, exactly. And for example, rain, then it would have some configuration, like intensity of the rain, basically. It's officially hour 0, and we just discussed something pre-hack, have all the hardware here, and I'm gonna build the firmware side, and Alex gonna build the app side. I'm just going to jump in a bit here because I realized I didn't say anything about the architecture or how did we work. So basically, the firmware is written entirely in Rust just because it's fun and I'm very new to Rust. So I want to learn it a lot with as much chances as possible. So I always pick Rust for my new microcontroller projects, for my new embedded projects. Rust is number 1. For Alex, then he built his iOS app in SwiftUI. Originally, he built it in UI kit, but then he switched it to SwiftUI in day 2. And the two components communicate with each other with protobuffer. We developed our own communication protocol for application layer to drive this light. Why? Because, well, first of all, using any other serialization method would be a lot of overhead. I don't want that. It's got to be optimized, you know? But furthermore, I just want to learn as well, for Alex as well. We don't have a lot of chances to use protobuf like in day-to-day development. Like, who would use protobuf unless they have gRPC? But yeah, it's a good chance to practice this method. And yeah, I think you will have enough context to review the next videos or the next logs now. Yeah, we shall see. And we have our first update on the progress. So what have you worked on?
So far we just have a core architecture.
Oh, nice.
For the app. So far just looks black.
I just finished compiling the core as well. Had some problem with the path. The Windows sucks because it has like long path thing where it can't compile if you have the too long path. Second hour update. So what have you done?
So now we have a color picker.
Oh, nice.
And now we also have small throttle so that we don't spam it too fast.
Oh, nice.
So yeah, we can do this.
Still have a lot of problem with the path. So ton of problem with the build. For some reason on this chip, the firmware doesn't work as before. So now it just crashed after it connects to the Wi-Fi. I'm still figuring out how. But the protobuffer is updated. So it's much more horizontal now. So things aren't nested together and it's much more easier to understand. There's a new logic to it. But I think you can figure that out. Third update.
So I'm trying to get protobuf working with Swift. So we apparently have Swift protobuf plugin that we can use directly from Apple. So that's working pretty nice.
It is working now?
Yeah. So I can make models directly in Swift already.
Oh, nice.
Yep.
On my side, then I'm trying to get protobuf to work. Apparently, the package I used yesterday is producing some errors that I can't fix, so I use another package which is proving to work well. But it's having some decoding error. So yeah, hopefully next hour I can solve that. So this is hour 4, and basically I just updated the protobuf, and everything works now. Yeah, good news that everything works, and I can have a Python file that pings the device. Okay, here it is. Yeah, so you can see. Okay, so wait, what hour is it? Is it hour 5 already?
5.
No way. Okay, so what you've been working on?
So I'm trying to do the Luna client thing, and so far I'm just trying to see what it returns and try to print it out.
Oh.
But so far no good luck. So I can connect and I know it's connected, and I can send a state and I can get a response, but for some reason I can't parse the response.
Have you tried like the Python test?
No.
Yeah, you should maybe try that. Then you know exactly if my code has a problem or is it yours. Okay, 6th update. On my side, then I added 2 new threads, a render thread, and especially for running the LEDs. I haven't actually tried and run the LEDs yet, but I'm working towards that. Hopefully by 6 p.m. then we have some functionalities done. And yeah, I updated the protobuffer, so now it returns the current state. What about you?
So I'm mostly fine-tuning the client side now. So I'm just trying to make it battle tested. And I think until 6 o'clock we should have UI for this one, for the states and for the pickers. So whenever you move this one and you select a state, it should actually make requests.
Okay, this is hour 7.5. I just soldered the test board. Haven't seen if it works yet. And yeah, let's turn to Alex. Alex just solved the problem.
Well, from my side, I completely misunderstood the way we did request and response. So it was not working for 6 hours. And now by mistake we figured it out. So now it works. But that took a lot of time for me to complete the UI. So now I'm just starting with the UI.
Oh, shit.
So UI will be done with 15 to 20 minutes.
Oh, nice. Okay. Just check out for hour 8. So our 8.5 update. I found out the error with the light strip. It was because I plugged in the wrong cable. And yeah, I fixed it. And now we can proceed to the main logic of the firmware. And let's go to Alex.
We have some UI right now. So you have the selected state, you have the sliders, you have that thing. So right now I'm trying to finish the selection state so that you can select it and it would switch over, and then after that I'll make the network calls.
Nice. Yeah, so... Huh. Okay, can you actually push the sky button? Nice. And now what if we push the basic control button again? Interesting.
I think
What can cause... Nice. Okay, it's the second day of the hack. Alex is here. And what we basically have was the app is probably still the same, right? Yeah. And the firmware is, the modes are all done and they're all modularized in different files. So now I can just create a mode, add it in without any hassle. And the testing LED is done. Now we can stop focusing on the firmware, start focusing on the app, and work on the 3D design of the light itself. And you can see the fish tank right there. And yeah, hopefully I'll do a more in-depth dive of how the actual modes work. But yeah, let's have a look at them working. So this is basic mode. And we wait for 5 seconds, I suppose. Holy shit. It doesn't work anymore. What? Okay. Hour 1, day 2, short update. So on my side, then I already designed let's say I designed the casing of the LED. It's going to contain 2 components, and the first one is the LED holder, which is basically a cylindrical thing, and I have all my measurements here. And the next thing is the board holder, which is going to hold the Seat Studio Xiao ESP32C6 board along with millimeter wave sensor, and that's going to be like this. And yeah, I already designed the first cylinder in Fusion 360. It's printing right now. Okay, now comes to Alex.
I mean, on the website, I just updated the protobuf schema because we updated it, so I did it here, and now also updated from the closure base to async stuff so that we can use SwiftUI instead of like.
Okay, hour 1.5 mid update because we're gonna have a lunch break right now. You can see the food right here. My mom is prepared for us. And the thing is still printing. We have a lid now. The lid design is in progress. And hopefully everything fits. What's about you?
I have a small SwiftUI app now that can control everything.
Oh yeah, let's see.
So now we can swipe it. The sky.
Is the rain mode?
Yep. Meteor. Apocalypse.
Third update. A lot of cool things that happened. So we got the light ring, the plastic light ring, and I've also installed the LED inside. You can see it's a very snug fit, good design. And yeah, there's a test board right here, some wires here, and everything works. Everything works. So like, it even works from the app that Alex has built as well.
So small UI updates. It's inspired by the Apple Weather app.
Yeah.
So like you have the modes, you have the basic control, you can go into, and then you can like preview the colors.
And it actually works.
I don't think it's connected now. I think you're right there. Yeah?
Oh,
it actually works.
Yeah, it actually works.
So you can change them, change modes.
Okay, so 4th update. Nice. Yeah, so I basically designed the top part to hold the microcontroller, and it's being printed right now. But yeah, we had a working prototype of the light, and it's currently mounted on this tank. I've also put in something in there so we can like actually judge how the lights affect plants. And yeah, just like the CRI or the color index of this. And yeah, hopefully in 1 hour we'll have a complete unit when this finishes printing. And on Alex's side,
and mostly we build the whole. This is a long time. I'm still building, but we build the whole picker. So now I add some animations and feedback.
See,
But
you can literally see it, right? Yeah, cool.
yeah, but right now
There's haptic as well. Oh.
crop the view a bit. So
There's no more haptic, right?
okay, that's good. Bring it back.
Yeah, so that's the 4th hour recap. Hopefully by the 6th, we'll have everything. Alex, say hi to the group.
This is first step.
Yeah, there's Slack. Okay, this is the 5th update, and we got the hardware done. It looks super cool, and it works first try. We're gonna try to boot it up with the firmware and see where it goes. And on Alex's side, he just made the super cool app. Let's see.
We decided to add some videos, so they're not optimized, and this is just a proof of concept.
So freaking
I'm
cool.
adding the settings so that we can write the IP address here.
Nice.
Last update, we have an app. We have the lights. Everything works as planned. And I guess the total hour that we work on this is less than a day.
10, 12.
Yeah, and we span it over like 2 days. But we honestly just work on this like each day 6 to 10 hours. So that's insane that we can bring a very cool iOS app. There's a basic mode. Now comes the sky mode. And then bring everything from the drawings to the actual 3D print, the casing of this, and the actual firmware that runs it, which is insanely long. We managed to pull it off. Yes. Sup. So I just finished editing this video, and it's probably the end of the video. But there was a lot of things that I didn't or wasn't able to include in. For example, like the whole process of aquascaping this aquarium, or the whole process of just like sketching on paper for designing in Fusion 360, or just like simply soldering stuff. And that's because I try to make this video as transparent as possible for each logs to be in a sequential timeline for you to understand the process, to you to understand the raw problems that we encounter along the way. And I hope that doesn't make this video super boring, because I think it would be super boring compared to my other videos, for example, where I try to put everything in a more entertaining way. And as a last note for this video, I want to say a big thank you for Seed Studio, especially Lily, for sending me these stuff on such a short notice and such fast transportation. The Seed Studio ESP32 C6 from Seed Studio, should definitely buy it if you have projects that require small electronics, because this is probably the smallest MCU you can probably get, right? Like a whole unit. And yeah, consider if you want to buy from them. I have an affiliate link down below. I'm not monetized on YouTube yet, so that would help me a lot. And also, if you enjoy watching this video or not enjoy watching this video, leave a comment below so I can know where to improve for next videos. Thank you for watching.